All right, so this is the first video of our proof practice. And so let's start with our first statement and then given information that segment GB is parallel to segment KO, and that is given. And then from that given information, what we can look at is that if we look at angle 2 and angle 3, we would see that what we have from those parallel segments is that we have alternate interior angles. And so we can then say that angle 2 is congruent to angle 3. And our reasoning for that, parallel lines imply that alternate interior angles are congruent. So right now we have a pair of angles, and if we look to our next set of given information, it tells us in statement 3 that our segment JK is parallel to segment OB. That is also given. And then what we can do from that point is to look at angle 1 and angle 4 and say that we have angle 1 congruent to angle 4. And once again, that would be that parallel lines imply that alternate interior angles are congruent. And so now we have two sets of angles, and what we should see is that this side is shared. And so we can say that segment JO is congruent to segment JO, and that is the reflexive property. And then that will give us enough information to be able to say that triangle OJK is congruent to triangle, and we need to be careful here, make sure that we get the notation correct, that is going to be O goes with J, and so if we look at that, that is going to be JOB. And our reasoning behind that, we have angle, and then an included side, and then an angle. All right, if we look at the next one here, let's start by looking at some of the given information and see what we can draw out from there. So let's start with that segment DU is parallel to segment OE, and that is given. So we have DU parallel to segment OE. And what's going to happen there is that we're going to create some alternate interior angles with those transversals. So we're going to look at angle O and angle U. And so we're going to be able to say that angle O is congruent to angle U, and parallel lines imply alternate interior angles are congruent. And as well as, if we look at this other transversal coming through here, this is going to be angle D. And that's going to be congruent with angle E. Once again, same reasoning of those alternate interior angles. Now, you might have noticed that it said this proof can be done two different ways. If we stuck with drawing conclusions from our given information, our next natural step is, now that we've exhausted this first given, is to move on to this second piece of given information and to say that segment OU bisects segment DE, and that is given. But then from that information, we can pull out that if that's a bisector, then what must be true is that N is the midpoint of segment DE, and that would be the definition of a segment bisector. But what we really need is we need that side. And so what happens next then is if N is a midpoint, then segment DN is going to be congruent to segment EN, and that's our definition of a midpoint. And so that means that we have this to this. And so then what would happen is that next we now have enough information to be able to say that the triangle UND is congruent to triangle ONE, and that is by angle, angle, side. Now, you might have thought, if gone all the way to step 3, another way to look at this problem is just to use this first piece of given information, and then instead of going the route of looking at the segment bisector, you could say that we have vertical angles in here, and we could say that angle 1 and angle 2 are vertical angles by the definition of a vertical angle. Angle 1 and angle 2 would then be congruent to each other by the vertical angle theorem, which would end up with us either using angle, angle, side, or angle, side, angle. So that is an alternate approach, drawing on the information of vertical angles instead of using the second piece of given information. So if you were thinking about that you saw those vertical angles, yes, that is another route that you can go in being able to prove those triangles congruent. All right, so let's look at the third one here. And if we start with our first piece of given information, that triangle WUB is isosceles, then from that given information, we should automatically know that our next thing is that our sides, so that segment WU is congruent to segment BU. And that's the definition of an isosceles triangle. Okay. We should then link that to, if we know that those sides are congruent, then we know that angle W is congruent to angle B, and that is our isosceles triangle theorem that tells us that if we have congruent sides, that implies congruent base angles. And so now we have an angle. So we have side, we have angle. From this given information, I think that's all that we can draw. The next thing that we could do from the second point of given information is that S is the midpoint of WB, segment WB, and that is given. And so what that tells us, the definition of a midpoint, tells us then that segment WS is congruent to segment BS. And so what would happen then is that we can say that triangle WUS is congruent to triangle BUS. And that is going to be by, we have a side, an included angle, and a side. And so that's going to be side, angle, side. And now our last step is to say that angle SUW is congruent to angle SUB, and that's by corresponding parts of congruent triangles are congruent. All right, so let's look at number 4. Number 4 has some information filled in for us already. One thing I want to note is that look at what you're proving there. You're proving that segment GP is congruent to segment LP. So that means that in statement 6 here, we're going to need to prove that the triangles are congruent, so that in segment 7, we're then able to say that segment GP is congruent to segment LP, and that reason is going to be corresponding parts of congruent triangles are congruent. So what we're really, our main goal is getting the triangles congruent, and then we can draw that conclusion in step 7, okay? If we look at this, it has some given information already in there in steps 2 and 4. Let's look at what we could be able to draw just by looking at the figure itself. And what we might note is that we're sharing this common side here. And so what we're going to say is that segment PA is congruent to segment PA by the reflexive property. Now, how did I know how to do that? Well, both of my given pieces of information are in here on step 2 and 4, and then there's a blank underneath it. So what that means is that I need to look at this given information in statement 2 that says that segment PA bisects angle GPL. And so what that would tell me is that angle 1 must then be congruent to angle 3, because that's the definition of an angle bisector. Okay, so we have this angle to this angle. My statement here of given tells me that segment PA bisects this angle over here, GAL, and so that tells me that angle 2 is congruent to angle 4, and that once again is the definition of a angle bisector. Now what I have, let me mark that off there. What I have is an angle, and then we have a side, and then we have an angle. And so we are able to say that triangle GAP is congruent to triangle LAP, and that is angle, side, angle. And now we're able to take and look and say that segment GP is congruent to segment LP, and that would be corresponding parts of congruent triangles are congruent.